When sizing a pull box with conduits running out of 3 sides, specific requirements must be considered. We will determine the size of the pull box when there are 5 1-inch conduits inside A, 3 1-inch conduits inside B running straight through, and 2 1-inch conduits inside C at 90 degrees from A and B. The first step is to determine the total number of straight-through conduits. Inside A, there are 5 conduits, and inside B, there are 3 conduits. This results in a total of 8 straight-through conduits. Next, we determine the number of 90-degree conduits. Inside C, there are 2 conduits making a 90-degree turn. Now, we calculate the minimum box size required for both the straight-through and 90-degree conduits. For the straight-through conduits, we use a calculation of 8 inches plus 2 inches, which equals 10 inches. This provides the minimum dimension for the section of the box accommodating the straight-through conduits. For the 90-degree conduits, the calculation is 6 inches plus 1 inch, which equals 7 inches. This provides the minimum dimension for the section of the box accommodating the 90-degree conduits. An important factor is the overlap between the straight-through and 90-degree conduits. Since the 2 conduits inside C will overlap with some of the conduits inside A and B, we must account for this overlap. To do so, we add 2 inches to the straight-through size. Therefore, 10 inches plus 2 inches equals 12 inches. Based on these calculations, the minimum required size for the pull box is 12 inches by 12 inches to accommodate all the conduits properly. Using a 12-inch by 12-inch pull box provides ample space for the conduits, ensuring they can be terminated and arranged within the box in compliance with the National Electrical Code. It is essential to adhere to the NEC guidelines for sizing pull boxes to ensure safety and proper functionality of the electrical system. The National Electrical Code Section 314.28 addresses pull and junction box requirements for conductor sizes number 6 American wire gauge or larger. The NEC specifies different rules for straight pulls versus angle or U-pulls. For straight pulls, the minimum dimension of the pull box in the direction of the pull must not be less than 8 times the trade diameter of the largest raceway. This is to ensure that there is sufficient space for the conductors to be pulled through without damaging them. For angle or U-pulls, the distance between each raceway entry inside the box and the opposite wall must not be less than 6 times the trade diameter of the largest raceway in a row. This requirement ensures there is adequate bending radius for the conductors, preventing insulation damage and ensuring proper electrical connections. When different raceway sizes are installed in the same row, the calculation is based on the largest raceway in that row. The NEC also specifies that after installation, the conductors must not be damaged. Sufficient space within the pull box is crucial for this purpose. The depth of the pull box must be sufficient to accommodate the lock nuts and bushings in the raceways. In addition to the NEC requirements, there are practical considerations for sizing a pull box. A larger box makes it easier to work with the conductors, especially when dealing with larger gauge wires. Adequate space allows for proper bending and routing of the conductors, reducing the risk of insulation damage and ensuring reliable connections. If future modifications or additions to the electrical system are anticipated, it is beneficial to install a slightly larger pull box than the minimum required size. This provides additional space for future conductors and simplifies the installation process. When using a pull box, it is important to properly support the box to prevent it from sagging or shifting. Support methods include using brackets, straps, or other appropriate hardware to securely mount the box to a stable surface. Proper grounding of the pull box is also essential for safety. The box must be grounded in accordance with the NEC requirements to minimize the risk of electrical shock. The grounding conductor should be properly sized and securely connected to the box using approved grounding methods. The selection of the pull box material is another important consideration. Pull boxes are typically made of metal or non-metallic materials. Metal boxes provide better mechanical protection and are suitable for use in areas where physical damage is a concern. Non-metallic boxes are corrosion resistant and are suitable for use in damp or wet locations. The cover of the pull box must be securely fastened to prevent accidental access to the conductors. Covers are typically attached with screws or other fasteners. The cover must be rated for the environment in which the pull box is installed. For example, a weatherproof cover is required for outdoor installations. The pull box must be installed in an accessible location, allowing for future maintenance and inspections. The location should be free from obstructions and provide adequate working space around the box. Consider the weight of the conductors when selecting a pull box. Larger gauge conductors can be heavy and may require a more robust box to support the weight. The box must be able to withstand the weight of the conductors without deforming or collapsing. When installing multiple pull boxes in a raceway system, it is important to coordinate the locations of the boxes to minimize the overall length of the raceway. This reduces the voltage drop and improves the efficiency of the electrical system. The conductors within the pull box must be properly identified to facilitate future maintenance and troubleshooting. Each conductor should be labeled with its circuit number or function. Y markers or other identification methods can be used for this purpose. It is important to use the correct type and size of connectors for terminating the conductors in the pull box. The connectors must be compatible with the conductor material and size. Improperly installed connectors can cause overheating and electrical failures. The conductors within the pull box must be neatly arranged to prevent tangling and overcrowding. This makes it easier to work with the conductors and reduces the risk of insulation damage. Cable ties or other methods can be used to secure the conductors in place. When working with pull boxes, it is important to follow all safety precautions to prevent electrical shock. Always to energize the circuit before working on the pull box. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. Inspect the pull box and conductors regularly to ensure they are in good condition. Look for signs of damage, such as cracked insulation, loose connections, or corrosion. Replace any damaged components immediately. When making modifications or additions to the electrical system, be sure to update the pull box accordingly. This may involve adding new conductors, replacing existing conductors, or changing the size of the box. Always comply with the NEC requirements when making changes to the electrical system. Proper sizing and installation of pull boxes are essential for the safe and reliable operation of electrical systems. By following the NEC guidelines and best practices, you can ensure that pull boxes provide adequate space for conductors and facilitate future maintenance and inspections. When using reducing washers to connect conduits of different sizes to a pull box, ensure that the reducing washers are properly sized and installed. The reducing washers must be made of compatible materials to prevent corrosion. When installing conduits into a pull box, use appropriate bushings or connectors to protect the conductors from abrasion. The bushings or connectors must be properly sized for the conduit and conductor sizes. When pulling conductors through a conduit system into a pull box, use lubricant to reduce friction and prevent insulation damage. The lubricant must be compatible with the conductor insulation. When terminating conductors in a pull box, use appropriate torque values for the connectors. Over-tightening the connectors can damage the conductors, while under-tightening can result in loose connections. The NEC provides torque specifications for various types of connectors. When installing ground bars in a pull box, ensure that the ground bars are securely mounted to the box and properly bonded to the grounding system. The ground bars must be sized to accommodate the number of grounding conductors. When installing splices in a pull box, use approved splicing methods and materials. The splices must be properly insulated and protected from mechanical damage. The NEC provides requirements for splicing conductors in pull boxes. When installing control wiring in a pull box, separate the control wiring from the power wiring to prevent interference. Use separate raceways or compartments for the control wiring. When installing fiber optic cables in a pull box, protect the fiber optic cables from bending and crushing. Use appropriate cable management techniques to maintain the minimum bending radius. When installing data cables in a pull box, avoid running the data cables parallel to power cables to prevent electromagnetic interference. Maintain a minimum separation distance between the data cables and power cables. When installing low-voltage wiring in a pull box, use appropriate terminal blocks or connectors for terminating the low-voltage wiring. The terminal blocks or connectors must be rated for the voltage and current of the low-voltage wiring. When installing fire alarm wiring in a pull box, use fire-resistant wiring and connectors. The fire alarm wiring must be installed in accordance with the fire alarm system requirements. When installing security system wiring in a pull box, protect the security system wiring from tampering. Use tamper-resistant screws and covers for the pull box. When installing communications wiring in a pull box, use shielded cables to prevent interference. The shielded cables must be properly grounded to the grounding system. When installing instrumentation wiring in a pull box, use appropriate instrumentation connectors for terminating the instrumentation wiring. The instrumentation connectors must be rated for the voltage and current of the instrumentation wiring. When installing renewable energy system wiring in a pull box, use wiring and connectors that are rated for the environment in which the pull box is installed. The wiring and connectors must be resistant to sunlight, moisture, and temperature extremes. When installing electric vehicle charging station wiring in a pull box, use wiring and connectors that are rated for the voltage and current of the electric vehicle charging station. The wiring and connectors must be installed in accordance with the electric vehicle charging station requirement. When installing industrial control panel wiring in a pull box, use wiring and connectors that are rated for the industrial environment. The wiring and connectors must be resistant to chemicals, vibration, and temperature extremes. When installing hazardous location wiring in a pull box, use wiring and connectors that are approved for use in hazardous locations. The wiring and connectors must be installed in accordance with the hazardous location requirements. When installing marine wiring in a pull box, use wiring and connectors that are approved for use in marine environments. The wiring and connectors must be resistant to corrosion and moisture. When installing underground wiring in a pull box, use wiring and connectors that are approved for direct burial. The wiring and connectors must be resistant to moisture and soil conditions. When installing temporary wiring in a pull box, use wiring and connectors that are approved for temporary use. The wiring and connectors must be installed in accordance with the temporary wiring requirements. When installing multi-conductor cables in a pull box, use appropriate cable clamps or connectors to secure the cables. The cable clamps or connectors must be properly sized for the cable diameter. When installing shielded cables in a pull box, ensure that the shield is properly grounded to the grounding system. The shield must be grounded at both ends of the cable. When installing coaxial cables in a pull box, use appropriate coaxial connectors for terminating the coaxial cables. The coaxial connectors must be properly crimped or screwed onto the coaxial cables. When installing twisted pair cables in a pull box, use appropriate twisted pair connectors for terminating the twisted pair cables. The twisted pair connectors must be properly wired according to the wiring diagram. When installing fiber optic cables in a pull box, use appropriate fiber optic connectors for terminating the fiber optic cables. The fiber optic connectors must be properly polished and cleaned before installation. When installing data communication cables in the pull box, use appropriate data communication connectors for terminating the data communication cables. The data communication connectors must be properly wired according to the wiring diagram. When installing low voltage power cables in a pull box, use appropriate low voltage power connectors for terminating the low voltage power cables. The low voltage power connectors must be properly rated for the voltage and current of the low voltage power cables. When installing high voltage power cables in a pull box, use appropriate high voltage power connectors for terminating the high voltage power cables. The high voltage power connectors must be properly rated for the voltage and current of the high voltage power cables. When installing control cables in a pull box, use appropriate control connectors for terminating the control cables. The control connectors must be properly wired according to the control circuit diagram. When installing instrumentation cables in a pull box, use appropriate instrumentation connectors for terminating the instrumentation cables. The instrumentation connectors must be properly wired according to the instrumentation circuit diagram. When installing signal cables in a pull box, use appropriate signal connectors for terminating the signal cables. The signal connectors must be properly wired according to the signal circuit diagram. When installing communication cables in a pull box, use appropriate communication connectors for terminating the communication cables. The communication connectors must be properly wired according to the communication circuit diagram. When installing network cables in a pull box, use appropriate network connectors for terminating the network cables. The network connectors must be properly wired according to the network circuit diagram. When installing electronic cables in a pull box, use appropriate electronic connectors for terminating the electronic cables. The electronic connectors must be properly wired according to the electronic circuit diagram. When installing computer cables in a pull box, use appropriate computer connectors for terminating the computer cables. The computer connectors must be properly wired according to the computer circuit diagram. When installing audio cables in a pull box, use appropriate audio connectors for terminating the audio cables. The audio connectors must be properly wired according to the audio circuit diagram. When installing video cables in a pull box, use appropriate video connectors for terminating the video cables. The video connectors must be properly wired according to the video circuit diagram.